All right, let's take a look at some of these multiple choice questions. Here on number 1, they are asking us to solve an absolute value inequality. And what I want to do here is just kind of use the answers to help me make sense of this. Well, I can see that I have a less than statement, so I can immediately throw out option B because that has included endpoints that would have to be a less than or equal to. I can also throw out solution C because this absolute value will have a solution. The only time I don't have solutions if I have an absolute value related to a negative number. So really, I need to figure out, do my solutions converge? Do they come together here? Or do they diverge on option D? Well, if I have a distance from 0, an absolute value that is less than 4, that distance is going to be smaller rather than larger. A must be my answer. Didn't even have to do really any math here, just some analysis of the question and answers itself helped me get to a correct answer. Number 2, we have to do a little bit more algebra here. I'm going to pause just to keep the video short. So there you can see my work. I came up with the inequality that x is less than or equal to 14 over 11. In other words, x must start at 14 over 11 and go to the left on our number line. That will be option C. Here on question 3, this is kind of a written out absolute value type problem. Let's make sense of what they're asking first. So they tell us that a number is subtracted from -7. So -7 minus x. The absolute value of that difference is more than 3. When we have that negative inside the absolute value, that makes things a little bit more complicated to evaluate. So I'm going to solve this absolute value inequality. I'm going to say that -7 minus x must be greater than 3, and that the opposite of -7 minus x is also greater than 3. So if I were to solve this first inequality on the left here, I would add x to both sides and subtract 3. So I would have x is less than -10. There's one part of my inequality. And my other inequality, I can multiply everything by -1. You know what? Let's do it this way. Let's distribute that negative in. So I'll have 7 plus x is greater than 3. I can subtract 7 from both sides. So x is greater than -4. So I just have to choose the solution that meets these criteria. I go numbers less than -10 and greater than -4. That will be option C. Again, here we have an absolute value inequality. Again, I want to try to eliminate answers as quickly as I can. I see that I have a less than or equal to. I'm going to eliminate option B because that has excluded endpoints on the number line. If I have an absolute value that is less than or equal to, that should be converging solutions that center on the point -5. Basically, I'm going to have x plus 5. Its absolute value should be less than or equal to 5. So -5 will be the midpoint of my solution set, and I'll go 5 in either direction. That will be solution D. We're moving on to some graphs here, identifying parent functions and transformations. On number 5, they are just trying to ask us to name this function. This is a square root function, just based on the shape and the limited domain. We can see here that our graph stops at 0. On to number 6 here, they ask us to take the absolute value graph and transform it. These two transformations are a vertical stretch and a horizontal compression. So we're not moving up, down, left, or right. We're not moving vertically. So I can eliminate some answers. Option D can be eliminated because we are not multiplying by a negative. Option C can be eliminated because we have not shifted right or left. Option A can also be eliminated because the negative inside the absolute value does not flip us over the x-axis, but rather over the y. That means that B is the only possible option. So there, we didn't, even not knowing a ton about transformations, we could eliminate answers that don't make sense. That's a big key to these multiple choice questions. On number 7 here, we're going to have a quadratic function stretched and reflected vertically. So we can see that option A wouldn't work. It hasn't been reflected vertically. B hasn't been reflected vertically. And D hasn't been reflected vertically. Therefore, C must be our answer. That negative sign out in front of the 2 tells us that our graph should open downwards. On number 8 here, we have a linear function shifted up 2 units, and its slope is 1/2. This should be an easy one for us. Let's see, I'm looking at the y-intercepts. That allows me to eliminate options B and C. And I should have a flatter slope as opposed to a steeper slope. A is our answer. Number 9, we have a combined function, f plus g of x. Our 2 functions are linear functions. They have no domain restrictions, so when I combine those functions, it will also have no domain restrictions, leaving D as the correct answer. Finally, here on number 10, we have a firm considering a new product. We have a cost function, you can see C of x, and a revenue function, R of x. They want us to interpret the solution here. They tell us that no more than 871 units can be sold at that price, okay, based on whatever price was given. They ask us to find and interpret R minus C of 871. All I need to do to interpret this is to evaluate R of 871 and subtract from it C of 871. All we're really doing there is plugging in quantities into each of these functions and subtracting their results. Well, I did that off page here on my calculator, and I got R minus C of 871 to equal 2,700. What that means, that's our revenue minus cost. That means that's our profit function. We've made $2,700, so we can eliminate A and D. If we've made $2,700, it is worth it to develop this product because we are making money.